Okay, I'm going to go through part 4 of this run through. Sorry, it's been a bit of a delay since part 3, but I also work full time, so I've already done 3 parts. As I said, this is the Pearson Edexcel IGCSE for the physics and combined science double award. So it's paper 1. So if you haven't seen the first 3 parts, it's in the same playlist as you'll find this one. And if you go back and watch those, don't forget to show your appreciation by giving a like to each video you watch that you find helpful. Share it with any friends who you think would benefit by looking at these videos. And make sure you subscribe, because more videos will be coming in the build up to the final exams for the 2025 series. Okay, so we went all the way through questions 1 to 8 in the first 3 parts. Okay, just a little comment. So I've got a few people who've seen the first 3 parts already. I do these mainly for my own students, and they can use them to improve their own understanding once they've tried these papers. So I basically do them as I do them with my own students. And a lot of students elsewhere are also watching them, which is great. But I'm getting people watching and then wanting to get clarification on some theory or some misunderstanding that they may have. And without liking the video, they're just asking questions and expecting answers. So this is not a free service in terms of tutoring, but if you would like me to answer your question, the least I expect you to do is to give a thumbs up to every video you watch and to help the channel grow. Otherwise, I'm going to concentrate mainly on A level, because those videos get far more views than the GCSE ones so far. So if you want more videos like this and you want help with answering your questions, I expect thumbs up for all the likes for every video you watch, and I expect you to help me to grow the channel. The more likes and shares I get, and the more requests I get for future GCSE videos, the more likely I am to do them. Okay, because time is limited and I do this on top of my normal 9 to 5 work. Okay, so question 9 is from the topic solids, liquids and gases, which my students did at the beginning of year 11. It's about air pressure. Okay, so it's to do with the kinetic theory of particles and how the tiny little particles inside, for example, air in this bottle, how they produce pressure. So it says, during an aeroplane flight, a passenger drinks some water from a plastic bottle, shown in the diagram. The passenger then replaces the top to seal the bottle, as shown in the diagram. Okay, so basically, when they're flying, the pressure when you are in mid-flight is lower than atmospheric pressure on the ground. So that's what you've got to be aware of. And you see the air, most of the bottle is empty, so he's drunk most of the water. And it says the air pressure outside the bottle is 80 kilopascals, yeah, while he's in midair. Okay, so pressure inside the bottle will be the same, 80 kilopascals, because if it wasn't the same, the bottle wouldn't keep its shape. Okay, and you'll see what I mean in a minute. State the air pressure inside the bottle just after the bottle has been sealed. So he's drunk the water, and then the air from the cabin takes the place of the water, and of course the air from the cabin is the same as when the lid was open. So when the lid up here was unscrewed, the air just replaces the water that you drunk. So the air pressure inside and the air pressure outside will be exactly the same. Okay, and it'll be whatever the cabin pressure is. Okay, so you just have to write 80 here, 80 kilopascals. I didn't use the pen, I used the highlighter, but you get the point, and that's how you get the mark. Okay, so because at that mid-flight pressure, the balanced pressures, yeah, inside the cabin and inside the bottle, because the pressures will balance each other, they will move for the pressure inside the bottle to equal the pressure outside. So it has to be 80 kilopascals. and that's how you get that mark. Okay. Part B says the aeroplane descends, yeah. As it descends, the air pressure inside the aeroplane changes. They haven't told you, but as I told you before, it's going to increase. The closer you are to landing, the greater the pressure is going to be, okay? Because atmospheric pressure is based on the height of the atmosphere. So the deeper in the atmosphere, lower you are in it, the more air there is above you, and that's what pressure is. It's the kind of the weight of all the air above our heads, okay? And normally it's about 100 kilopascals. So in the air, in the bottle, it was 80 kilopascals. So when the airplane lands, the passenger notices that the plastic bottle has collapsed, partially at least. Yeah, hasn't totally collapsed, as shown in diagram 2. Now remember, inside, the air inside was at 80 kilopascals when he closed it. When he sealed the lid, the cabin pressure was 80 kilopascals. So the pressure outside the bottle, because when he's landed, the pressure outside the bottle must be greater than the pressure inside the bottle, because when you land, the pressure of the atmosphere is more like 100 kilopascals. So pressure in mid-flight was 80 kilopascals, yeah? And the pressure on landing is about 101 kilopascals, average atmospheric pressure, okay? So when landing, the pressure outside the bottle is greater than the pressure that was trapped inside the bottle. Explain why the bottle has collapsed. Well, what I just explained to you is the explanation. This, all of this, is the explanation of why it collapsed, okay? So the points you need to make when you're explaining this to the examiner is there's a difference in pressure. A triangle means there's a difference in pressure, so which I explained up there, yeah? The pressure outside the bottle must be greater, yeah, than the pressure inside the bottle. So that's, will get you some marks. So therefore, if there's a difference in pressure, there will be a resultant pressure or force inwards, because pressure is force per unit area, yeah? So you can talk about pressure being force per unit area as well, if you want to. And that's how pressure and force relate to each other, okay? So you can also say that you know Boyle's law. If the pressure increases, the volume will decrease, yeah? So P1V1, when he was at 80 kilopascals, the volume was bigger, and then now the pressure outside has changed. It should then squash the volume because the pressure now outside is 100 kilopascals, so the volume shrinks to equal it. So these are all points. Now let's have a look at the mark scheme when we finish this to see how many marks we would get through, and it's about detail and clarity. So I've given you 3 bullet points, and with this is like a 4th point that you can mention, all right? It then says, for part C, explain how gas molecules in the air microscopically exert a pressure on the surface of the bottle, yeah? So, and that could be from the inside or from the outside. Random motion of particles. So remember, the molecules are moving about randomly because that's what gases do. The particles and gases are just randomly moving about and colliding with whatever they hit, including the container that they're in, a bottle, collide with the wall. And each collision produces a force or exerts a force on the area of the wall. And pressure is the sum of all these collisions or sum of all these forces per unit area, yeah? So again, these are the bullet points you need to put in to get the 3 marks. And total of this question is only 6 marks. And it's quite a lot of explaining, so there's not much maths, yeah? 5 marks on this page, and it was just 1 mark on the page before to understand that when the bottle hadn't collapsed, the pressure inside must be the same as the pressure outside in the cabin, yeah, that they'll be equal because it's not collapsing. But then over here, when you land, the pressure outside the bottle is 100 and the pressure inside is 80. So the difference is 100 to 80, yeah, 100 compared to greater than 80, yeah, that there's difference in pressure, and that's what causes the resultant force inwards, yeah, to cause it to collapse inwards. That'll be a force because pressure and force are related by the area that the pressure is acting on. Okay, so let's have a look at the mark scheme and see how many marks you think we deserve. So first of all, 80 kilopascals, we got that mark. And then it says any two from these points. The pressure in the aeroplane increases when you land. Yeah, so the cabin pressure increases. So in other words, they want you to understand that there is a pressure outside the bottle is greater than inside the bottle. And that's exactly what I said. Okay, and this causes a force inwards. Yeah, because the pressure outside is greater than the pressure outside is greater than the pressure inside. And remember, pressure is simply force divided by area. So that's what causes the force inwards, the greater pressure outside. And the third mark that you could get instead was the idea that decreasing the volume in the bottle increases the pressure in the bottle, and that's how it equalizes the pressure. It equalizes it by squashing the molecules inside. So when the bottle collapses, the volume goes down, so therefore it can get to the same pressure as outside the bottle. So it's a form of equalization. Okay? By the volume contracting, it equalizes. And in part C, how do particles actually create it? So movement of the molecules in a gas is random. That means they're moving haphazardly. Yeah. The molecules collide with the bottle surface. Yeah. And so they will let you use bounce. Yeah. Collide is the best word. Yeah. Hit the wall. Yeah. They don't want you to talk about molecules colliding with each other, which they will do, but they want you to explain how it produces a pressure on the bottle. Okay, so they want you to concentrate on the surface of the bottle. All right, then each of these collisions exerts a little microscopic force on the bottle, and pressure is a sum of all these forces on the area of its bottle, which creates pressure. Okay, and then they like it if they will allow you to give the formula format. Pressure is force over area. So this formula is useful to include in your answers. Okay, so that's question 9. Question 10, one of my students was doing this question today and he said, well, what is this experiment? And I said, well, it's just an experiment and you've got to analyze it, but it's about forces, so it comes from topic 1, forces. Okay. Diagram 1 shows the apparatus a student uses to investigate the bending of a wooden strip. Yeah? So remember, you actually extended a spring probably when you did forces and materials. So this is, instead of using a spring which is made of metal and it can be stretched, this is the flexibility of a wooden ruler or a wooden strip. So here is the wooden strip. Yeah, and it goes all the way to here, and then it's bending because they put a load to weigh the end that's off the table, and it kind of pulls it down a certain height based on the amount of load. Okay, so part of the wooden strip is clamped to the table here, so that's holding it in place. This bit stays rigid, and the bit hanging off the end of the table is weighted down based on this load that they put, and load is measured in newtons. Okay, it's the weight of the mass you put on it. So it says a load is fixed to the free end of the wooden strip, causing the wooden strip to bend, okay? The free end of the wooden strip is positioned a distance or a length L beyond the edge of the table, okay? So there's another clamp here, so it can't bend between the clamps, it can only bend beyond the edge of the table, as shown in the diagram, okay? So we have a scenario. So all of this is just reading. You've got to absorb the information, and this is what happens towards the end of the paper. They're getting used to more difficult questions, getting used to being able to do A-level type questions, and this is more A-level in terms of its design. It's easier than A-level, but it's the same point. It then tells you the weight of the load causes the end of the wooden strip to move through a height h, yeah, which I put an arrow to, yeah, this is the height that it bends, and that's one of the things they're going to measure. It says a student investigates how the length, yeah, that hangs over the edge affects the height that it bends. So one is the independent variable, the length is the independent variable, and the height that it bends is what you measure and depends on the weight and the distance from the clamp, okay? So these are the two variables that you need to vary and measure, okay? The load of the mass was 250 grams, so the mass is, 250 grams, yeah, which is a mass of 0.250 kilograms, yeah, so calculate the weight. To calculate the weight, you need to multiply the kilograms, not the grams, by 10 for GCSE. So it tells you to use the formula given to you as weight equals mass in kilograms. They want to see that you've changed it to kilograms. That's one of the tricks they use to see which students have revised carefully. And the weight will be in newtons, because the gravity on Earth is basically 10 newtons per kilogram. So it's like a way of converting kilograms into newtons, and you multiply the two together and you'll get the answer 2.5 newtons, and all you need is two significant figures, okay? That's how accurate you can be. They're giving you the unit for these 2 marks, okay? The question continues. The student, this is the student's method for the investigation. He says, clamp the wooden strip so that L equals 20 centimeters. So that's the independent variable, so that's going to change, but initially he does it at 20 centimeters. And then fix the load, 250 grams, to the end of the wooden strip as shown in the diagram on the page we just looked at. Then measure how much it dips the vertical height that it bends, which I told you was a dependent variable. Okay, so the student then repeats this method for different values of L. So you always choose how to change your independent variable, and then from that you measure your dependent variable. Okay, change L, measure H, and so they want you to give the independent variable in this investigation. Well, I've done it for you. Okay, all you've got to do is understood what I've put. So the independent variable is the length from the edge of the table, and the dependent variable is the height H in the diagram. Okay, length L, height H will get you the 2 marks. And then it wants you to think, okay, we know what independent variable is, we know what dependent variable is, then they want you to give 2 controlled variables in this investigation. Okay, well, they didn't say they're going to change the mass, because you only change one thing at a time, so the mass of the load, 250 grams, must be kept constant. Yeah, because that's a key factor. Now, what else do you think they could accept? Because they've got other suggestions, and we'll look at the mark scheme now, in fact, because the next part we'll come back to, because it's a little bit more involved. So what else would they accept as a control variable? Can you think of anything else? Okay, so they'd accept the mass of the weight, which we got. They will accept the position of the load, didn't change, they always put it right at the edge of the wooden strip. Yeah, so that would be a good one to put. The thickness of the wooden strip hasn't changed, they'd accept that. And the material that they used for the wooden strip hasn't changed. Well, these two are kind of basic, but these two are the good answers. So if it was me teaching you, I would tell you to put the first 2 bullet points as your answer. Okay, he's chosen what the mass should be and exactly where it should be attached to the wooden strip. Okay, so then part A we did before, yeah, working out the weight so you can see the answer. And now we're going to go to part 3, but let's go back and read the question. You can stop the video if you want to have a look at whether you deserve the mark or not. So the idea of these YouTube videos is that you've already done the paper, you've self-assessed, and then you want to see how you could improve. So the audio explains to you the points that may not be clear by just reading the mark scheme. Okay, so the final part of this investigation, it says students suggest how the student could accurately measure the height h. Okay, so obviously to measure the height h, you would need first an implement, a tool, and a meter ruler would be the best thing to suggest because all labs have them. Yeah, and the best thing to do is to fix the meter rule vertically near where it's bending and keep it in place so it doesn't move. Yeah, so you're not constantly having to move it, and then you see how much it's moved from the starting position. And ideally you could put the 0 of the ruler at the original position of the wooden strip before it was bending. Yeah, so the kind of level with the table where it was clamped, but close to the other end. And then you've got to say how to ensure that you've got your meter ruler vertical. Yeah, so you could use, so for example, if you got your meter rule here and this is the floor, you want to put something to make sure this is a right angles here. And what you could use is a set square. Those triangles, so you could put the set square there, and to show that the ruler is placed exactly vertically, and therefore you're not getting any errors due to a poor alignment. And then it says also to get accuracy, when you're taking the meter rule is bent and it's come to down here, so it's original, this would be the 0 point. You want to measure the height that it bends up to here, that you should avoid parallax error and look at that at eye level. Yes, so avoid parallax errors when reading the H means get down a bit like the tennis judges do and put your eye exactly in alignment with where the ruler has dipped to. Okay, and the use of set squares is a common way of making sure that you've done things accurately. Okay, you could even put a set square here to make sure that the edge of the ruler is aligned exactly with where you're reading it. Okay, now isn't that smart? Okay, so I hope this diagram helps you understand. So these run-throughs is not me answering the question, it's telling you the kind of things you should think about when answering these questions. So any two from use of a meter rule, fixed in place at the end of the wooden strip that's bending, yes, the side that's bending. Put the 0 of the ruler place at the original height of the wooden strip, which would be the table height, yes. Method to ensure measurement is vertical, yeah. You can use what's called a plumb line, which is just basically a piece of string with a weight on the end, hanging downwards, and the weight on the end. Make sure that the string is placed downwards. And you can just see that the ruler is then parallel to the plumb line. So the plumb line is just a piece of string with a weight on it. Or the set square method, which I showed you with a right-angled triangle, which are commonly used. And take your measurements at eye level, yeah, to make sure that you are avoiding parallax errors, okay? They won't like it if you just say avoid parallax errors. You need to tell them how. That's what this means, okay? All right, well, I hope this makes sense to you. And then they get your data. So that was the method and the validity, like making sure that you're measuring exactly what you think you're measuring, so your data is going to be valid. And here they're giving you the table results. So here's the different lengths that they used in centimeters, from 20 all the way up to 120. Yeah, so they haven't measured it to the nearest millimeter, they've just measured to the nearest centimeter. So you could comment on that. Could they have measured it more accurately? And the height, that means how much it dipped, is also measured in centimeter. Yeah, and one piece of data is missing, which probably means they want you to do it. Yeah, the diagram here, diagram number 2, shows the wooden strip when L was 80 centimeters, so this value, they want you to use that. This value there they want you to look at. So, shows the wooden strip when L is 80, yeah? So the distance that they're telling you is 80. There's the starting height. You can see I've drawn my meter ruler and made sure I put it vertical. So if the floor was here, if the floor was there, I could then put my set square, it's called, these triangles, there to make sure the ruler is definitely vertical. And then you take your readings here, again using the set square, to make sure you avoid errors in your accuracy of reading. Okay? They want you to use the diagram to determine the height h that is spent in the laboratory, and you've got to use this scale. So you want you to get your ruler out, and 1 centimeter's diagram represents 10 centimeters in the lab. So they want you to measure it with your ruler where it would be, and then work it out. Well, I measured it to be 3 centimeters with my ruler. So make sure you bring your own ruler with you. Make sure it's a see-through ruler. It's much better than any other ruler. And therefore the height in the lab would be 10 times bigger, because 1 to 10 ratio in real life would be 30 centimeters. And I've put 30.0 to show that I'm doing it as accurately as possible. Okay? So this is about methods of getting accurate data. This is all this question. So to answer the student who was doing this question today, which is why I'm uploading it today, because I'm falling behind with keeping up with the YouTube videos, is basically understanding the scientific method for investigating anything scientific. So they could give you a question on anything, and you just got to think scientifically to show that you know what reliable means, what validity means, how you control the variables, etc. And that's what makes something valid, is by controlling the validity, and reliability is how well you take your measurements to make sure you don't have unforeseen inaccuracies. Then they want you to plot a graph of the student's results. Yeah, remember you did one for them. And then they want you to draw the curve of best fit. So they're telling you it should be a curve. And the smooth, they see I've drawn my smooth curve. Yeah, you don't join the dots. Okay, so you get a mark for having suitable scales. And I've obviously gone up in 10 centimeters upwards for the height, 10 centimeters per square. Always use multiples of 1, 2, or 5. And here, each 2 squares is 20, so it's the same. 20, 40, 60, yeah, 80, 100, 120. And you see we had data, so we're using the whole size of the graph paper provided. And of course, if there was 0 load, yeah, then you would have for 0 length would be 0, there would be no dip. So I know it should go through the origin. So it informed me that's where I should draw it. And you can see this is the only point that doesn't really sit on the nice curve. So you shouldn't try to force it, okay? So accurate plotting gets you the second mark. They will check to see that you've plotted accurately. If they think that you're more than one little square out, you will lose the mark. And then finally, the 15-mark question. So it's the biggest question in the exam. It says the student concludes that H is directly proportional to L. So they're checking to see that you know that what is directly proportional means. And directly proportional means it should be a straight line going through the origin. Well, obviously, a curve is not a straight line going through the origin. So you can evaluate the student's conclusion straight away by saying the student is wrong. Yeah, the student is wrong because it's not a straight line and it doesn't go through the origin. Okay? So you got to go more than my bullet points. You've got to talk about it's not a straight line. Sorry, it's not a straight line. And it doesn't go through the origin, therefore it's not directly proportional, therefore the student's conclusion is incorrect. Yeah, so it's not a straight line, doesn't go through the origin, that's how you've got to put it. This graph is a smooth curve, not a straight line. Yeah, so these points are related. Yeah, and then so you say the student's conclusion is incorrect. And that is the 15 marks that will get you a big advantage if you can do these kind of questions. So the correct measurement, they say, was 3.1 centimeter. Yeah, well, maybe if this was the original exam paper, but this is the one that I printed on my printer. Mine, I definitely got it closer to 3.0. Yeah, but it will be fine. If you measure it accurately, they will know that you're within their range. But you can see they're accepting anything between 3 and 3.2. So even though I wasn't using original paper printed from the exam board, it's within their range. And then the suitable scale, you want to make sure that you have got plotting correct to the nearest half square, and suitable linear scales chosen that uses all the grid or as much of the grid as possible. Okay, and there was their 31, and I would have put 30 there. Acceptable curve of best fit is drawn. That means that it doesn't join all the dots, especially between 20 and 120. They weren't worried about the 0 point. Okay, so when they're looking to see if it's a best fit, they want the smooth curve with points distributed equally either side. Well, mine were going so well that only one was off the line, and I didn't force it. And the final point, idea that proportionality requires a straight line, and direct proportion means there has to go through the origin. Okay, so that's what you need to know. And the graph doesn't show this, so you've got to say the graph does not show this, therefore the student is incorrect. Okay, and that's how you get the final 2 marks. All right, so there's your 15 marks. Now, do we have only one more question? 11? No, we got 2 more. So I'm going to pause there because these are quite long questions towards the end, and I'll come back and do 11 and 12 in the next video. So remember, if you find these videos useful, please share them with your friends, because if I don't get enough people watching the GCSE videos, and if I don't get enough likes, I'm going to keep doing A-level videos, because I have enough of those to do on their own that I don't need to spend time doing GCSE ones. So it's really because my students are doing them that I'm doing them. But if you want this to continue, you need to like, share, subscribe, and leave a comment if you have any requests. Okay, I've already got a request to do the January 2023 paper. So go and have a look at all of the different GCSE playlists that exists and see if it's useful, and just help spread the word if you think this is going to help other students. Okay, that's it for me. Bye for now. Catch you in the next video.